In this video, I'm going to talk about exponential growth and decay. So exponential growth and decay is when something is increasing or decreasing by a percent. That's going to be key to this. So exponential growth always follows the same equation. Y equals, or you could see f of x, a parentheses 1 plus r to the power of x. So a couple things you need to know here. Is this a value? Oh, sorry. This a value, this represents the initial value. That is the initial value. So whatever something is starting at, that's what you would put in for a. The r is the growth rate. Sorry if you can hear my dog in the background. R is the growth rate. Now, what's really important is, for example, if you have a growth rate of 5%, we cannot put 5% into an equation. You would have to move that decimal twice, so it's actually 0.05. Okay, that is key here when we're doing exponential growth and decay. So that is the equation for growth. And then over here on the right side, I'm going to show you the equation for exponential decay. And so again, we have to be decreasing this time, decreasing by a percent. So if we have decay, sorry, the pen's a little smaller. The equation is going to be very similar. The only difference is it's going to say y equals a and then 1 minus r to the power of x. That's the only difference. So the a is still your initial value. And then the r this time will be your decay rate instead of your growth rate. So these are your formulas. And so what we're going to do is I'm going to look at our notes real quick and just show you some examples. So here you can see, again, that formula that we just wrote down is right there. And right here, okay, something is growing at an annual rate of 15%. We needed to change that to 0.15. So in my equation, you'll see 0.15, not 15%. So the equation, I put 500 in for A, or 5,000 in for A, because that was the initial population. And then I put the increasing rate right there. Don't forget the 1 plus, and then you can simplify it. Then it said, what will the population be in for 5 years? So I took the X value, put 5 in, and then that's how I got 10,057 people. So if we scroll down, if it will let me scroll down. Here we have another example. Something was increasing by 76%, so that is exponential growth. We changed that to 0.76. So when we put that into the equation, we see that 0.76 there. And then we have the 1 plus because it's increasing. And then the decay, we have minus. Again, the decay rate has to be converted to a decimal. So if we have 25%, if it is decreasing by 25%, it's 0.25. If you want to go ahead and pause the video to read that question, please feel free. But I'm just trying to give you the highlights. So what I like about decay is we can really see the point of the 1. Because a lot of people always forget the 1. They don't see the point in it. But if we think about the fact that something is decreasing by 25%, then what's left over? If we take 25 away from 100%, we're left with 75%. And then we can really see that in the decay function. So I'm just trying to show you why it's so important to have your 1. So whether it's growth, whether it's decay, A is always your starting value, R is your growth or decay, and then X is how long it's been since the initial. And sorry, one more thing, you don't always have to simplify, but you certainly can. It'll make it easier when you go to solve.